Welcome back. In the last few lecture sessions, we have learnt about algorithms and some data structures. In this unit, I will discuss about testing, debugging, exceptions and assertions, which are very important aspects in any of the programming languages. Let us see one by one. First one is testing. So what is a testing? It is the process of running a program to try and find out whether it works or not for the purpose it is written. It's very clear. If we write a program for a specific purpose, first we have to run that program and check whether it works or not. So if it is working, then we have to try all possibilities. If it is not working, we have to check where we have went wrong. And the second one is debugging. Debugging is the process of trying to correct a program that is already known not working for the purpose it is written. So debugging follows testing. In the sense, if the program after testing is not working, we have to go back. Go back and check where there is an error, where we went wrong. So stage by stage. So normally programs are broken into separate components that we know, like functions, classes, structures, etc. so that it is easy to test and debug. So normally instead of testing the whole program, some part of the program like functions, classes, they are tested. So finally, it is easy for us to determine where the error has occurred, where we have written a wrong syntax or a wrong code or a wrong sequence, etc. can be tested instead of trying the whole program. So that is very important as far as debugging is concerned. Let us go in detail into the testing aspects. The purpose of testing, as we know, is to show that bugs exist, not to show that a program is bug-free. So while doing testing, we have to check all possibilities so that at the end we can conclude the programs that we have written is bug-free. For that purpose, we have to generate an extensive sequence of inputs, also outputs. They are called test suite. Let us define test suite. What is a test suite? It is a collection of inputs for testing. It must have high likelihood of revealing bugs, yet takes less time to run. So the last word, yet takes less time to run. So within a short period of time, it has to reveal the bugs which is there in the program with all possibilities of inputs. So let us take a simple example. So this program we have written even in microprocessor and microcontroller. If I want to find the bigger of two elements, I have written a function. I call that function as bigger. There are two parameters here, x and y. These are the two inputs. Now what normally we do is to compute, to find out the biggest of the two elements, we give two positive numbers, one smaller one and another one bigger. Run the program, it will show us the x is the biggest. Then we interchange that one, we make the second one the biggest, then it displays y is the biggest. We will not go for giving all possible inputs to this program. Now, whenever we want to generate a test suite, we create a test suite rather, we have to give extensive input. In this case, for example, I have two inputs, x and y. What is the first possibility? Take both x and y as negative numbers. Then run this program. Then take x as negative, y as positive. Then x as positive, y as negative. And last one, x as positive and y also as positive. So give all possible bipolar inputs to the program so that it will produce correct output if I run this program. So that is an example of a test suite. Let us go to the next one. It is a classification of testing. Normally, testing is classified into two types. First one is called black box testing and second one is called glass box testing. What is a black box testing? It is a technique based on looking into paths through specification. A glass box testing. It is a technique based on looking into paths through the code. Let me elaborate. A black box testing is one where we do not run the program. Okay, so we look into the program, different sequences of the program flow, wherever there is a syntax error, etc. And then we normally move on to the second one. So after black box testing, we do glass box testing. A glass box testing is one where the sequences, the execution of a program will be through the code. That means the program is edited using an interpreter or a compiler. Then it will be executed. The whole program is run. Then we will try to check where the bugs are present. Okay, this is called glass box testing. So normally, if both black box and glass box testing are successful, then it will be approved. The program will be approved, is working as per our specification. If it is not working in these two stages, then we have to go to a process called debugging. Let me see what a black box testing is in detail. As I told, a black box testing is done without looking at the program. Point number one. Point number two. In case of black box testing, developers and testers are two different groups. They are isolated. Developers are one group of people and testers are another group of people. Testers do not know what developers are doing and developers don't know what testers are doing. They are totally isolated. Hence, their aim to identifying an error, why if it is not working during the process of testing, is totally different. Point number three, since test data is generated without the knowledge of implementation, it is robust. The test data which is generated by the testers doesn't have the knowledge of how it was implemented by the developers. Hence, it is robust when compared to an integrated group of both developers and testers. Point number four, boundary conditions should always be tested, like if it is a list, test with empty, one element, list within the list, etc. That means all possible conditions are to be tested. So in this example case, if the list is an empty list, no elements are present in the list. If the list consists of only one element, and if there is a list inside another list, all these possibilities are to be tested. They are called boundary conditions. Then only we can say our testing is robust. Let us take an example and see how this will work. I have taken the example of a function. A function is written here for copying one list to another list. I call L1 as the source list and L2 as the destination list. I have to copy from L1 to L2. Here it is, whole thing is kept under a while loop. This while loop will run only if the destination list length is greater than 0. Okay, so if there is no element in the list, it will come out. Then otherwise it will enter inside the loop. You see here, first what I am doing is L2.pop. if there is any element present inside the destination loop, take it out. Pop, the function, built-in function pop is used for the purpose of emptying a list. If any element present at the destination, you empty it. So that from list L1, I can put contents onto L2. Then use a for loop for E in L1. So a for loop is used to iterate through each and every element of the source list L1. So E is a variable, an integer. It goes through each and element at index number 0, index 1, 2, 3, 4, so on. And for each element in E, the for loop enters into another state where L2 is loaded with the element which is present at the source, that is at L1. For that purpose, I use another built-in function called append. Append E, the element which is present at a specific index of L1 is to be loaded onto corresponding position of L2 by using L2 dot, a dot operator, L2 dot append E. So this will put the content which is there at a specific position in L1 to L2. So this will work fine. If L1 consists of some elements, then each element will be taken and it will be loaded onto L2. This will not work if L1 and L2 refers to same list. How? At the first instance itself, if I am doing L2.pop, L1 will also be emptied. So that the first condition, while if the length of the list is greater than 0, then you enter inside. At the first instance itself, it will not enter, it will come out. The for loop will not be executed even once. So this is the case where the program will not work for all possibilities. So if L1 is empty, L2 is empty, L1 is consisting of only one element and L1 consists of list within. If we check all possibilities, if both source and destination are the same, this will not work. Hence, we have to put some condition here. So this will not work for such and such a condition. Right? So this is about the testing, black box testing. So in the next class, I will discuss about another type of testing that we have already seen, which is glass box testing. Thank you.